So we're starting off with ALEKS problems today, doing them first, because these problems are going to help you see what the point is of oxidation numbers. Like, why are we even doing anything with oxidation numbers? What is the point? In the last set of stuff, all that we were doing was learning how to assign oxidation numbers, and I told you that then once you figured it out, we would learn what you're supposed to actually do with them. So we're going to use oxidation numbers as a way of figuring out if a reaction, first of all, if it is a redox reaction or not, and then we can also use it to figure out if something is being oxidized or reduced without having to write the half reaction out and actually look at the transfer of electrons. So we've got 4 different reactions here, and in each of these reactions, one atom is highlighted, and it wants you to decide if that highlighted atom, iron in the first example, is being oxidized or if it's being reduced, or neither. It's just not undergoing any kind of oxidation. And the fastest way for us to figure this out is to assign oxidation numbers. We don't need to assign oxidation numbers to everything. We really only need to assign oxidation numbers to iron as a reactant as well as a product. So we need to see if the oxidation number of iron is changing, and if it is changing, how is it changing? So I'm going to write that bigger because it's actually pretty small. We have iron oxide, FeO, and then we also have iron atom, Fe. So we'll start with iron oxide, and we're going to use the rules. Remember, we know that oxygen is always a -2. We know that the sum of the oxidation numbers has to add up to the overall charge, which is 0 for iron oxide. So that means that in this compound, the oxidation number of iron is a +2. So this iron right here has to be a +2. For the iron all by itself, atomic iron, anytime you have a single atom all by itself, and it's not an ion, it's just a single neutral uncharged atom, its oxidation number is always 0. How do I know that? Because some of the oxidation numbers has to add up to the charge. And if we just have one single atom with no charge at all, that atom has to have an oxidation number of 0. So because the oxidation number has changed for the iron, it has gone from a +2 down to a 0, the oxidation number has been reduced. This is a reduction. Remember when I told you that when we use the oil rig, oxidation is loss, reduction is gain, and I told you that whole reduction is gain doesn't kind of make sense, as those words mean opposite things. Well, this is why we call it a reduction. It's not referencing the change of electrons, it's actually referencing the change in the oxidation number. So when the oxidation number goes down, it's always a reduction. So let's look at the next reaction. This is CO plus H2O, and the hydrogen is highlighted. And then over on the product side, hydrogen is highlighted again. So here we're comparing H2O versus H2. And we know that hydrogen, just under normal circumstances, it's always a +1. One of the exceptions would be in the H2 molecule where it's a 0. So here, again, we have the oxidation number going from +1 down to a 0. It's again being reduced. The oxidation number is being reduced, which means hydrogen is being reduced. Let's look at our next reaction. In the next reaction, we are focusing on carbon. That's the highlighted atom. We have a CH4 versus a CO2. So we need to figure out the oxidation number of carbon. We know that hydrogens are +1, and we have 4 hydrogens altogether in CH4, so that's a total of +4. We know that the carbon's oxidation number plus the hydrogen's oxidation numbers altogether has to add up to 0, the overall charge. So this carbon's oxidation number is a -4. For CO2, we know that oxygen is a -2, and we have 2 of them. So that's a total of -4. The carbon has to have an oxidation number of 4 because the carbon plus the oxygen also has to add up to 0. So in this case, our oxidation number is going from -4 to 4. The oxidation number is going from -4 up to +4. That is not a reduction. The oxidation number is not going down, it's not being reduced, which means carbon is being oxidized. And we have one more example. Our last reaction, I'm going to make some room for it. Our last reaction, we're comparing carbon again. We're comparing Na2CO3, ooh, that's going to be a hard one, versus CO2. Our CO2, we just did CO2. So we already know that the carbon in CO2 is a +4. So let's figure out the Na2CO3. Well, we know that sodium is a +1 ion, and there are 2 of them, so altogether that's a +2. And we know that oxygen is a -2 ion, and there are 3 of them, altogether is a -6. And our carbon plus the sodium plus the oxygen has to add up to 0. So what do we need this carbon to be so that this number and this number and this number adds up to 0? It looks like it needs to be a 4. So here we are going from an oxidation number of 4 to 4. No change. If there's no change, it is neither oxidized nor reduced.